Boys, have we ever been scrolling and seen this
Indian guy named Gohar
saying that AP Physics 1 is the hardest class?
because it requires a lot of conceptual knowledge. This is exactly that. If you get this question right,
Like, that's 3 points on the exam, okay?
so you need to recognize this question type, where they give you a graph, and the x and the y-axis give you another thing. So in this case, force times time is impulse, but this also works with velocity times time. That's going to give you displacement. There's also acceleration times time, which is going to give you the change in velocity. There's force times displacement, which is going to give you work. So you need to recognize this question type every day of the week. They give you no numbers, nothing.
It's purely conceptual.
So what can we do? We can find, what College Board wants us to do, is find the area underneath the curve, and then using that, we're going to get impulse in this case. This said velocity instead, and this said time, which it does. You're going to get displacement instead, right? Does that make sense? So every day of the week, you need to be able to find the area underneath the slope or the curve. So the area for this one is going to be, TF times F1, right? Because the height is F1. And then this one is going to be F2 minus F1. That's going to be the height, right? Times TF all over 2. Okay? So now we just need to add these together. So we can factor out TF. We can put F2 minus F1 over 2. Now you just add F1. And that is going to be our answer right here. So which one of these is that? I think it is this one. Yes. All right. You need to recognize this question archetype. Area underneath the slope. That's going to give us our desired value, which is impulse. So this one is literally might be the easiest question I've ever seen. So it's asking for linear momentum. For this entire video, I'm going to just write with M, because I know some people get tripped up when they see P instead of. So that's just going to be mass times velocity. So that's going to be equal to 3 times 4 equals to 12. That is our answer. Next question. Boy. So this next question is asking for velocity of the clay block system immediately after, so I know it's looking for final velocity. So it also sticks to the block. So the formula we can use is the conservation of momentum, which is m1 v1 plus m2 v, that should be initial, equals m1 plus m2 v final. So in this case, it's going to be mc2v plus mbv equals mc plus mb over times vf. So if it's asking for vf, well, all we have to do basically is just bring it over to this side. So we just divide both sides. So we get 2mcv plus m. Alright, I don't care anymore. mbv. Actually, I do care. My fault, guys. Over mc plus mb equals vf. And boom, there's our answer. So which one of these is that? Oh shoot, they substitute out a v, so we got to do that too. Come on, guys, you're overcomplicating it, College Board. So it's going to be D. Yeah. D. Good, that's pretty easy, right? Conservation of momentum formula is super, super important, especially for perfectly inelastic collisions, which is when they stick together. Okay? Next question. So this one is asking for mechanical energy. So guys, we remember about energy. Energy is going to be 1/2 mv squared. So it's asking for mechanical energy, which is total energy within the system, which is going to be the energy of the two guys. So let's calculate that. Ke, maybe I should use a smaller boy. Ke initial is equal to 1/2 m 2v squared plus 1/2 2m v squared. Okay, so now let's just simplify. 4v squared, 2mv squared plus these two cancel out, mv squared. That equals 3mv squared. Okay, so I'm going to zoom out. And now we need to find the final kinetic energy. So final, terrible handwriting. by Michael Pang. It's going to be 3m, right? Because it's going to be combined, because they stick together, right? Make sure you know that. V squared. So all we need to know is find V squared. What is the V? What is the V? What is the V? So we can use another question or another equation, which is conservation of momentum. Conservation. Maybe this is too big. So let's do that. It's going to be m1, which is m, times v1, which is 2v, plus 2m times negative e, because it's the opposite direction, is equal to m1 v final. Oh, they do stick together. My fault. m1 plus m2 v final. So in this case, it's going to be, this is 2mv minus 2mv. Okay, so this is just 0. This is just 0. Plus m2vf. And you know the masses can't be 0, so the final velocity is also 0. So, oops. This is just 0, okay? Ke final is just 0. So the change is the final minus the initial, which is just 3mv squared is the change. So our answer is going to be D. Okay? Next question. So this next question is also, bro, Gohar would be super proud of you if you got this right. Super conceptual. So anyway, conceptually, we need to understand that when an elevator is moving up with constant acceleration, constant is just another way of saying linear. So when the elevator moves up, the acceleration looks like this. Right? I'm not saying anything fancy here. So now, how can we relate acceleration to momentum? Well, we do know that momentum is equal to P is equal to mv, right? So how does acceleration correlate with mass? It doesn't. How does it correlate to velocity? It does a lot. So what we need to understand is that we can use the kinematic equation, Vf equals Vi plus At, right? Now let's just substitute in some values. So it says it starts at rest, right there. Vf equals At. So boom, now we have a solid way to relate acceleration and velocity. So as acceleration increases linearly, velocity also increases linearly as well. So in this case, what do you know? It's increasing linearly, right? I mean, it's kind of obvious, right? So as acceleration increases, velocity also increases. And notice how there's no square signs, right? There's no to the power of 2 or anything, which means that the relationship between acceleration and velocity is constant. It's linear as well. So I'm just going to draw that out for you. It's going to look like this, okay? It's not going to look like this. It's not going to look like this. It's not going to have any curves. It's just going to be linear. So remember that. This is super, super important. The relationship between acceleration and velocity is not linear. It's not parabolic. It's linear. So get out of here, boy. And then now we're just left with the linear functions. So is it going to be... So as you know, it starts from rest, so it needs to start from 0. So it can't be this one. Can't be this one either. It has to be B. Okay? Pretty easy. Pretty light. Super conceptual. All right, boys. Oh, graphs, my favorite. So graphs, they basically give you the answer. So they're giving us force times time, which is just impulse. F times t equals impulse. And then what is the question even asking for? It's asking for the change in momentum. So how do you, what even is change in momentum? So one thing that immediately stands out is the impulse momentum theory. Impulse momentum theory. So it sounds like super complicated, but it's so easy. So it basically says that I, which is impulse, is equal to the change in momentum, which is just okay, super easy. So what's the what can we find here? Can we find the impulse? Sure, let's find the impulse because it literally gives it to us right there. So what do we do, guys? What do we do? If you could a second to answer that, we need to find the area underneath the curve. So it's going to be 1/2 BH, which is going to be 0.002 times 2000 times 0.5. Okay, whatever. And then now, that's going to be equal to 4. I had that memorized. 2. So the impulse is going to be equal to 2. Okay? So 2 is equal to final. Did I just say impulse is equal to 2? Okay? Final momentum minus initial momentum. Okay. Final momentum is going to be, we do not know. So we don't know the final momentum, but are we given the initial momentum? Yes, we are. So the initial momentum is mass times velocity. And we're given the mass and we're given the velocity, which is 10 meters per second. One thing that's really important is that it's saying negative x direction, right? So the velocity is actually not going to be 10 meters per second. It's going to be negative 10 meters per second. So it's going to be 2 is equal to final momentum minus 10 times negative 10, I mean, times 2.5, negative 10. So that's going to be equal to 2.5 plus. Am I slow? Why did I write 2.5? It's 0.25. So this one's going to be equal to 2.5. So that means the final momentum is going to be negative 0.5. So what does this tell us? This means that the final momentum is going to go from 2.5 and it's going to go down to negative 0.5, which means it decreased. Okay, so now it's for the real question. Did the direction change? For me, what we can do here is we can realize that if it's moving at 10 meters per second this way, and then you have like a tiny freaking force, tiny off force this way, it's not going to completely reverse and change directions. Sorry if I'm not explaining this like mathematically, but I hope you guys understand, right? If you have a tiny freaking force that's 0.002 seconds, it's not going to go all the way. It's not going to change directions. It's just going to make it a little bit smaller. So that's my reasoning. So I know it's B. It did not change the direction. Okay. Next question. This one's also super conceptual. Like, it looks so easy, but it's not super easy. Okay. So when I do it, I'm going to make it look easy, but just know that they phrase it really confusingly. So anyway, what we can do here is, as asking for the resulting velocity, we can always use conservation of momentum. And the way I know how is because it's giving us mass and velocity and another mass. So what is the initial velocity? It's a trick question because it's 0. They're initially at rest. So 0 is equal to mass 1. What is mass 1? I'm going to make it the person. This guy can be Gert. He's Gert. 80 times 0.5, because that's the velocity, plus, chat, why did I not write the plus? 15 times VF. What are they asking for? They're asking for VF. Okay? So we're going to move the 40 to this side. 40 is equal to 15 VF. VF is equal to negative 2.7 because there's a negative sign. Okay? Meters per second. Okay, so that's going to be our answer. And the raft can be Yo. So Yo has a velocity of negative 2.7 meters per second. All right. Guys, I'm going to keep it a buck. I just lost all my recording footage because it got corrupted. But it's okay because making videos is fun. And it's my passion to see in the morning when I wake up a Yon P saying TS So Kevin in the comment section. Anyway. So this next question, it's asking for the direction of momentum. So anytime you see momentum, you need to think mass times velocity, right? And direction, velocity is a vector, right? Velocity has direction, which means if velocity is positive, it's going to be to the right. And if velocity is to the right, that means momentum is also to the right. So let's see, is the velocity positive or negative in T1? That's right. It's going to be all positive, which means from 0 to T1, it's going to be moving to the right. So it can't be B or A. Now, in T2, is it positive or negative? It's going to be positive velocity, which means it's going to be moving to the right, which means it's going to be moving to the right in both T1 and T2. Are we good? It's pretty easy, right? Right. So for this next question, it's asking about impulse. So impulse, as we know, is equal to change in momentum. Change in momentum is going to be equal to m v final minus v initial. So the first time, it's going to be hitting a foam wall. So I'm going to write impulse of the foam wall. And what happens is that it's moving in the negative direction. We're going to put this one as negative. We're going to put this way as positive. Okay, so when it's moving in the negative direction, it's going to have a velocity of v naught. So it's going to be m, 0, because it comes to rest when it hits the soft foam barrier. And it's going to be minus negative v naught. Well, and we know why we did this, right? Because it's moving in the negative direction. So it's going to be j naught is equal to m v naught. Okay? Pretty easy. And then now we're going to do when it replaces with the hard barrier. So I'm going to write I hard, which is equal to change in momentum, which is going to be m. V final. What is V final again? V final is going to be V naught, but this time in the positive direction, minus the initial, which is going to be negative V naught. So that's going to be equal to m 2 V naught. 2m V naught is double m V naught. So I hard is double I foam. So it's going to be 2j. Okay? All right, boys. So this next question, Loki, confused me a little bit. But basically, it's asking about when you push off another person, like on ice, will there be a change in momentum? So here's what we need to know. Momentum is always conserved, no matter. Actually, yeah. So for this next question, it's asking about when you push off an ice skater, is there going to be a change in momentum? So remember, momentum is always conserved unless always conserved unless external force acts upon it. Okay. Guys, rate my handwriting out of 10. Anyway, so external force is like friction or like air resistance, right? And remember, that's why we have the conservation of momentum principle, right? M1 VI. I literally have to write every single time because I know it always applies unless there's an external force. And in this case, there's no friction, it's negligible. Okay? So it's saying all three skaters and skaters B and C. So person A is stationary both times. So he's gonna be 0. His velocity is gonna be 0, right? For both systems, he's gonna have no impact on the momentum, which is mv. So in both cases, it's only gonna be skaters B and C, and they illustrate the concept of conservation of momentum because there's no friction, so there's no external forces. All right, are you good? So it's gonna be A. Momentum doesn't change in any other system. Can be D. No. So for this next question, it's asking about kinetic energy, right? So kinetic energy is just 1/2 mv squared. So what we're gonna do is we're gonna write the initial, Ke initial, is equal to 1/2 m, and it's moving at velocity v squared, plus 1/2 2m v squared. So this is just 3/2 mv squared, kinetic energy initial. Okay, now we need to find kinetic energy final. But here's the thing, it doesn't give us the velocity. So here's a way we can find velocity. What we can do is use the conservation of momentum, which is m1 v initial plus m2 v initial is equal to m1 v final plus m2 v final. So m1 v initial is going to be mv plus 2mv, which is equal to, it comes to a complete stop, which is 0 plus 2mv final. So this is going to be 3mv is equal to 2mv final, which means v final is going to be equal to, cancel out the m's, 2/3v. Okay? Right? No, it's going to be 3/2v. Sorry, guys. So now we can use that to find the kinetic energy. Kinetic energy, let me use a different color. 1/2 m. It's actually made 2m because it's a fat guy. The other guy is at rest. 2m, guys, 3/2 v squared. So this is going to be equal to, these are going to cancel out, it's going to be equal to 9/4 mv squared. So how does the KE final, how do these two relate? KE initial, KE final. So 9/4 to 3/2 is the same as 18 to 12, because when you cross multiply, 18 to 12, divide by 6 on both sides, that's 3/2. So that's our answer. Okay. Next question. So it's asking for final speed, and what I see here is a collision right here. So what we can do is we can use the conservation of momentum equation. So it's going to be m. It says m2 equals m1, so we don't need to write m1. We can just write m times v initial plus 0, because this boy's at rest, is equal to m1 plus m2 v final. Okay. So initially, v final is equal to m v initial over m1 plus m2. Oh, that's just 2m. V final is equal to vi/2. Now, let's see when the block is replaced with a mass of 2m. Okay, so now when it's 2m, now it's going to be 2mv plus 0, because the boy's still at rest, is equal to, this should now be 2m plus m v final. So now it's going to be v final is equal to 2mv over 3m. V final is equal to 2v over 3. So how do these relate? So the first one is 1/2 v. The second one is 2/3 v. So it's going to increase by a factor. It's not going to be a because it's not going to decrease. It's not going to be b because it's not going to decrease. It is not d because it doesn't double. So it's going to be c is our answer. So for this next question, it's asking about 2 blocks. So I already know. Anytime you see blocks, it's probably going to be conservation of energy. Or conservation of momentum, sorry guys. It's going to be m1. Actually, is there even going to be initial velocity? No, because it's held in place. So it's going to be 0 equals m1 v final plus m2 v final. So we know that the left block is twice the mass of the right block. So we can say 2m. And it's also going to be traveling in the negative direction. So we can say negative 2mv plus mv is equal to 0. So now we're going to bring that to the other side. It's asking for the speed of the left block, which is the fat one. So it's going to be 2mvf. Masses cancel out. We can't necessarily cancel out. Maybe I should have wrote v right over 2. Yeah, sorry guys. I'm tired. My voice, bro. So this is going to be v right over 2, which is going to be b. I got a volleyball game tomorrow. Anyway, you guys don't care. Anyway, next question is asking about impulse. Impulse is j, and it's force times time. Force times time. So usually, I don't really like using this equation because they never give you force, right? But this time, we can use mass times acceleration. They give us acceleration because they give us falling freely, which means a is equal to g times t. So the first time, it falls for 1 second. We're literally just going to cancel out the mass because the brick is falling for the first second and the second second, so it's the same brick. It's not being changed out, so it's just going to be 9.8 times 1 second. So J1 is equal to 9.8. Now, J2 is going to be equal to 9.8 times how many seconds? 1 second too. J1 is equal to J2. And why? Because the time and the gravity remains the same. So that's just, oh, see, literally says the exact same thing. Good job, Michael Payne. Good job, you. Great job. Next question. So this one's another conservation of mass, conservation of momentum equation. It's asking, is an external force applied? So anytime external force is applied, anytime there's an external force applied, that means there is no conservation of momentum. So let's see. Let's do it right now. Let's see if the conservation of momentum applies. If it does, then we're good. But if it doesn't, then we're not good. That means there was an external force applied. Okay, so this one is going to be 2v times 2n plus negative mv, because it's moving in the negative direction, so it's going to be 3mv. Now we need to see, is it equal to negative 2mv plus 2mv? So 3mv is not equal to 0. So that means there was an external force applied, because conservation of momentum is not applied in this case. So yes, because momentum is different. Next question. Yes, so this one is talking about a cart and a block. So I'm going to draw it out for you guys, even though I don't want to. Guys, I'm taking AP Psych. Let me know if you guys want Psych videos. So initially, it's moving 0.14 joules, and then when they crash together, they make a big boom. Now the block starts moving at 0.12 joules. So what is the energy of the cart after the collision? So what we need to know is that whenever it says elastically, they do not stick together. And that also means that mechanical energy is conserved. Guys, what is mechanical energy? Mechanical energy means Ke plus Pe, which means kinetic energy plus potential energy. So if the kinetic energy is conserved, that means the kinetic energy in every system is going to be 0.14 joules. So if it starts with 0.14 joules, it needs to end with 0.14 joules. So the kinetic energy of the block is 0.12 joules, and now it's asking for the kinetic energy of the cart. Well, we know that 0.12 plus Ke cart has to equal 0.14, because no mechanical energy is lost, which means Ke cart is equal to 0.02 joules. Okay? It stays the same. It remains the same always. Okay? Next question. So now it's asking how the internal energy of the block cart system changes. So what is internal energy again? Internal energy is all the stupid stuff like friction, air resistance, thermal energy, like sound, all that stupid stuff. So when I say mechanical energy doesn't change, that means only kinetic energy and potential energy. Okay? So if no energy is converted to like air resistance or friction or anything like that, that means all the energy is converted into kinetic energy and none of it is converted into internal energy at all. So it's going to be A. Why? Because no energy is converted to friction. It's always kinetic energy into kinetic energy. Okay? Mechanical energy is not lost during the collision. That's right. All right, next. All right, we're done with the problems, but let's say today you're working along with me, you only got like half the questions right. You only got 9 out of 18. Or maybe even less. Maybe you got like 5 or like 1, or like maybe you got every single question wrong. Even the College Board Rage Bait one, where it's like, what is the momentum, right? Even if you got that, don't worry, dude. You're more locked in than like everyone else who's just chilling on their phones. They're just like on TikTok or something. We have it on Friday, bro. We got this. We got a 5. We're getting 5s, bro. We're getting 5s. Okay, lock in. Today, tomorrow morning, tomorrow at lunch, tomorrow after school, tomorrow night. Make sure you lock in. Make sure you watch my videos. Make sure you get a great night's sleep. Bring that ruler. Bring the calculator. Don't download illegal programs onto your calculator. Don't do that. Don't do that. And yeah, we stay locked, boys. Let's go.